Hi, in this lecture, we are going to learn about finding the volume. Okay, previously we have learned about finding the area. So let's say the area of the region is as what I have shaded on the screen. And the volume of that shaded region revolving about the x-axis, revolving means is 360 degrees towards the x-axis. So it'll be a solid. Okay, it will be a solid, a 3D solid when we revolve it around the x-axis. So what if we revolve the area about the y-axis? So it will be a solid, a 3D object about the y-axis. Okay, so that's the idea of finding the volume. So what's the formula of finding the volume? Finding the volume is just the same formula as finding the area, but then we just add in pi in front of our integral sign, and we still have the same limits, which is from the bounded value of a and b, and also the function y is squared. Okay, so this means if we want to integrate with respect to x, or if we are revolving around the x-axis, this means everything must be in terms of x. And same thing if we are revolving around the y-axis, this means it must be in terms of dy, and then the value of the limits must be in y terms as well. Don't forget the pi in front of the integral sign, and don't forget to square the x function. So this x function will be everything in terms of y later on. Let's look at exercise 1. Please use your highlighter and highlight. Find the volume of the solid generated when the region bounded by the curve, this is our curve, and the lines 2 and 3, and the x-axis is rotated about the x-axis. So whenever we see the word rotated about the x-axis, or revolving about x-axis, or 360 degrees about the x-axis, this means that we have to integrate the volume with respect to x, or in terms of x. So from here, we can already write the equation to find the volume. It's just integrating with the pi formula in front, and then dx behind. Don't forget that we have to square the function. And since the function is only just one function, which is x squared plus 1, don't forget to substitute that function here, x squared plus 1. Okay, and then we already know the lines is from 2 to 3. So that will be our limit in terms of x. So make sure when you are integrating with respect to x, or revolving about the x-axis, the limits must also be in terms of x, where we start off with the smallest value and then the larger value. And then whatever function here should be in terms of x. So y as the title, and then everything is in terms of x. And you square it. So this square means it's not x squared and then 1 squared, but it means x squared plus 1 times x squared plus 1. So you have to expand it. And then simplify it first. After simplify, then you integrate. Don't forget, integrating is just adding the power with 1. 2 plus 1 is 3 over the new power, plus with 1 there's no x, so it's just x power 1. And don't forget to write the square brackets with the limits 3 and 2, which means you have to substitute the limit, the upper limit first, which is 3, and then the lower limit. Lastly, press your calculator and write the final answer. 838 over 15 pi unit cube. Moving on to the exercise 2. Next exercise. Find the volume of the solid generated when the region bounded by the curve, the lines, and the y-axis is rotated about the y-axis. So when you see it's rotated about the y-axis, this means we have to integrate in terms of y. Because this is finding the volume, you must use whatever the question is stated over here. Rotated about what axis? We have to follow that. It's not like area. If for area, you can choose whatever method you want to integrate, whether it's dx or dy. But for finding the volume, you have to follow the instruction. So if it's rotated about the y-axis, you have to follow. It must be everything in terms of y, so dy. Don't forget volume has the formula pi in front, and then you also have bracket square, where that bracket stands for the function in terms of y. So x is the subject, and then everything in terms of y, where we have only one function, it's just y squared minus 1, so substitute here. And don't forget your limit is from 0 to 2, where you get it from the question given. Smallest value below and largest value on top. So do notice that if it's in terms of y, then this is dy. Our limit is also in terms of y, and our functions are also in terms of y. Only then you can integrate. You cannot integrate if there is something that's in terms of x. Next, expand. And integrate y power 4 plus 1 becomes power 5 over 5 minus 2. Y power 2 plus 1 is 3 over 3 plus y. Substitute the upper limit first. Minus with the lower limit. Okay, so since the lower limit is 0, and you can see that this is 0 over 5, which is 0, 0 over 3 times 2 is 0, and plus also 0, you know that everything else should be 0. So for this question, you can just simply write 0. But it's not always true all the time. For example, for cos 0 is not equal to 0. So be careful with that. And also e power 0 is not equal to 0. So be careful if you have exponential and also trig terms when you substitute 0. Okay, now final answer would be 46 over 15 pi unit cube. Okay, moving on to the next part. What if we have two functions, and then we want to rotate the shaded region about the two functions, and it's revolving around the x-axis or the y-axis? So it's the same formula as what you have done before during finding the area, which is the outer function. If you are standing here, it's the outer function. Subtract with the lower function to get the middle shaded region. But now to find the volume, you just have to add in the formula, which is squared. You have to square the outer function first, minus with the lower function and squared. This means that it's not the outer function minus the inner function squared. It's not like this. It's each of the functions squared and minus. Okay? And don't forget there's also pi in front. And don't forget the limit is also in terms of x if we are rotating about the x-axis. And the limit is in terms of y if we are rotating about the y-axis. Moving on to exercise 3. Find the volume of the solid generated when the region bounded by the curve. Okay, so there is a correction for this question. It's not y equal to x squared over 4, but it's y equal to x squared over 2. Please do a correction over here. Should be over 2. Okay, so this is one of the curve highlighted as green, and then we have another curve which is y equal to 2x, and both of them is rotated about the x-axis. Okay, so since we know we have two curves, then the formula for the volume must be volume equal to pi integral. We must have two functions squared and subtract. And since it is rotated about the x-axis, this means everything must be done in terms of x, dx. So write dx at the end. So when we see dx over here, this means our limit must be in terms of x, and our functions here must also be in terms of x. It's just that whether it's the green function subtract with the purple function, or whether it's the other way around. Okay, so let us start by finding the limit first. So to find the limit, you just have to equate the function. The green colored function equate with the purple colored function. Make sure both have y as the subject, and then we can just write them side by side. For example, x squared over 2 equals 2x. And how to eliminate that square root? We just have to square both sides. Okay, solve them. X squared is x power 4. 2 squared is 4. And then you bring this 4 to the right side. We get 8x and x power 4 on the left. Then x power 4 minus 8x equal to 0. Next, you can factorize x power 1 because we have 1x here, and just take 1x over here. So what's left is 3 minus 8 equal to 0. So x is equal to 0 and x power 3 is equal to 8. So this means x is cube root of 8, which is 2, positive. So we have two values of x, which is 0 and also 2. So those two values would be our limits, which is the smallest number 0 and largest number 2. Try to substitute the functions into the calculator. Let's first try off with the green function, x squared over 2 squared minus with 2 squared. Key in on your calculator. You can ignore the pi because pi is definitely going to be positive. So you can just simply press your calculator like this. 0 to 2, x squared over 2 squared minus square root of 2x squared. And when you press equal sign, your answer is negative. So volume also cannot be negative, same as area. So that's why from here, we know that the function must be the other way around. So it should be set to x squared or minus x squared over 2. So from there, we know the function that we should write is square root x squared as square root 2x minus with x squared over 2. Then continue on integrating. So square meets square root is gone. X squared is x power 4. 2 squared is 4 dx. And then you integrate them. So just now we just simplifying the functions. Just square the functions. We have not yet integrate them. So now we are going to integrate them. So integrate 2x is 2x squared over 2 minus x power 5 over 4 times 5 is 20 with the limits 2 to 0. Don't forget to substitute your values. You can simplify the numbers. 2 squared minus 2 power 5 over 20 minus 0. And the final answer will be 12 over 5 pi unit cube. Don't forget the pi in front. So what happens if you forget the pi from each of the steps? Well, definitely since the formula of volume is wrong, then you will get everything wrong. Okay, so for exercise 4, there is a correction. The function is not x equal to 4 minus 3y squared, but it's x equal to 8 minus y squared. Okay, so start by highlighting the question. Find the volume of the solid generated when the region bounded by the curve, highlight the curve, and also this other curve is rotated about the y-axis. So whenever you see the keyword rotated about the y-axis, means that we have to integrate in terms of y. So you can start by writing down your formula of volume. Volume is equal to pi integral sign. Don't forget, this means if it's in terms of y, then the limit must also be in terms of y, and all of our functions here must also be in terms of y. But since we have two functions, so you have to start by writing down the brackets. So bracket squared minus bracket squared means it's for each of the functions. And then don't forget to write dy at the end. And since we are going to integrate in terms of y, and the limits must also be in terms of y, so we are going to find the value of the intersection points or intersection values in terms of y. So this means you have to make sure x as the title. So just equate them. 8 minus y squared equal to y squared. And solve. Bring y squared to the right side is 2y squared. 8 alone on the left side. And bring 2 to the left again, which is 8 divided with 2, which is 4. And it's equal to y squared. So this means y squared equal to 4. And then when you want to find y, don't forget this is square root and positive, negative in front of the square root. So this means value of y is positive negative 2. From here you have already found your upper and lower limit for the integral, which is negative 2 to positive 2. Now, without sketching, how do we know which function is to subtract which function? So if we sketch, we know that it's the outer function. We are standing here. It should be the outer function, the function which is highest, okay, which is furthest from us, minus with the inner function, okay. But if we don't sketch, how do we know that? Alright, so that's why we just write an error using our calculator. But since our calculator does not have the variable y, so please just change that y to x on your calculator, but don't get confused. Let's say we first try y squared minus with 8 minus y squared. Try on your calculator and see what is positive on the, and from your calculator you should get, we press equal sign, where y has been changed to x, the value is negative. Ignore that, you ignore the pi because you're just pi here, positive pi. So the answer is negative. So this means we know that the function should be the other way around. So let's try to change their places. Okay, so once you have changed your places, try to press equal. Now you get a positive value. So this means that this is the correct formula for you to integrate. But don't forget to copy the formula on your calculator, but with x changed to y. So it should be 8 minus y squared minus with y squared. Okay, and then to integrate this, you have to expand this 8 minus y squared first. Do not integrate yet. Okay, so 8 minus y squared is just 8 squared, 64. 8 times negative 1 times 2, negative 16y squared, plus negative y squared times negative y squared is positive y power 4, minus y power 4 dy. Okay, and I can see that this y power 4, subtract with this y power 4, it's gone. So what's left is just the other terms, 64 minus 16y squared dy. Now you can integrate it in terms of y. So y power 2, increase the power with 1, and now the limit is 2 and negative 2. Substitute your limits inside your y. Okay, so it's 2 first, subtract with negative 2. And just press your calculator, which we have done before, is 412 over 3 pi. Don't forget it's unit cube because it's volume. And you're done. Now for exercise 5, I want you to try it out yourself. Try to highlight. Okay. Find the volume of the solid generated when the region bounded by the curve and the line is rotated about the y-axis. So this means you have to integrate in terms of, yes, y. And to find the volume, what's the formula? The formula is pi and integrate of something squared minus something squared in terms of dy. Okay, so now you just have to find what are the limits and also which function to subtract with which function, which we have learned from previous 2 examples, exercises. Okay, so pause the video, try to answer it yourself, and after you are done, you can play the video again to see what's the correct solution. Good luck. Okay, time to check your answer. This should be your final answer. Did you get it right? If you did, congratulations. If you don't, try again. Thank you for watching.